Thank you all for coming. It is my great pleasure to introduce our keynote speaker, Professor Nick Duffield. Nick truly needs no introduction to this community, and I'm sure we would all prefer to hear what he has to say rather than listening to me. But let me just briefly say that Nick is a professor in the Department of Electrical and Computer Engineering at Texas A&M University, holder of the Wissenbaker Professorship, director of the Texas A&M Institute for Data Science, fellow of ACM, IEEE, IET, and twice recipient of the Sigmetrics Test of Time Award. His research combines foundations and applications of data science and networking. Without further ado, once again, it is my great pleasure to introduce Professor Nick Duffield.
Hey, well, thanks, Mark, for that introduction. And thanks very much for the invitation. Just wanted to check you can hear me okay and see my slides okay?
Yes.
Great. Okay. Well, I got to say, I was very pleased to receive this invitation. I hesitated a little bit to accept because actually I haven't been so active in Sigmetrics recently, but the chairs indicated this was actually a feature, not a bug, and that it was interesting to maybe hear about some things which are adjacent to Sigmetrics, even not essentially within it. And so this talk is partly technical. It's partly about positioning of the research we've been doing within a broader context. And I hope I can communicate some insights which might be interesting and even useful to people in the community. So the starting point for this is that universities are large and complex organizations. Texas A&M University, where I work, is maybe an extreme example of this. We have over 73,000 students, nearly 5,000 faculty. There are 17 colleges and schools, lots of undergraduate and graduate programs. And just to slice and dice this different ways, we have 2 US and 1 international campus. But the main campus in College Station has a huge area. Infrastructure, we've got cars, parking, bus services, bicycles, pedestrians, all aspects of transportation, buildings to run, maintaining their environment, their stage of repair, utilities within the university. And the research is over 1 billion in research expenditures, and this is conducted in the departments and over 150 centers and institutes. So this talks about operational data science. So what does that mean? That's using data science to enhance university operations and administration. And I find this pretty exciting because not only the benefits of doing this work for the operations itself, but also for the faculty and students. And I'm going to talk about 3 projects along these lines that we're conducting in the Operational Data Science Lab at Texas A&M. And I'm also going to talk about operational data science, draw some parallels between the kind of work that's done in universities and what's done in industry, and wrap up by talking about how the differences between these may inform recruitment practices going forward in universities. So, in the first few slides, I talked about the size complexity of the university, and what this presents to us is that the universities can be a living laboratory for data science, both in terms of being inspired by problems and also having impact. And data science can be an organizing theme between related operational problems. And there's an opportunity for us to improve those operations through data science. And what we found is that this works in 2 ways, what I call direct operational projects. So we partner with operational units in the university, and collaboratively we help solve their problems. But we've also found that in the adjacent areas, to those involved in solving these problems, we find that there's a broader set of problems in which we involve faculty, we involve collaborators, and they both inform operational problems, but also the work we do on the operational side, we find has impact in these adjacent areas. So the sort of spread of impact and opportunities of this work goes beyond the context of the university. And, but all this work, we find it's linked by a recurrent and reusable set of system components, databases, dashboard interfaces, visualization, and of course the underlying statistical modeling, machine learning, and AI techniques. But there's there's been a lot of focus, I think, in the last few years on becoming more interdisciplinary. But there's an additional focus here, which is vertically integrating all these components. And I think we see that it's an opportunity for our work. There are more opportunities, certainly in terms of research funding, to do work which has, harnesses theory to practice and impact. And I think this work in operational data science positions us well for that. I'm going to have some more comments about that later. So for the direct operational projects, as I've termed them, we have 5 going on at the moment. I'm going to talk about the first 3. One of which is the research dashboard for organizational intelligence. And what we're doing is a sort of graphical analysis of authorship and citations to identify research strengths and opportunities in the university. And we're partnering with the Vice President of Research organization in that. And also in the Division of Research, there's a second project concerning research compliance. So can we automatically identify risk categories associated with research proposals, animal, human, health, privacy, and so forth, because these are categories in the administration of research need further attention. There's regulations associated with this. On the operational side, we've been using computer vision for game day traffic measurement. So game day is the most demanding day for vehicle traffic in the calendar. We have 6 of these a year. And so we're using computer vision to do traffic measurement and support traffic planning and operations. And then we have a couple more projects, one on energy consumption and analysis, and another one on bike share effectiveness and operations. And you can read about those on our website, but I'm not going to talk about those 2 today. On the Cognate side, so well, we find that internally, every time we give a talk on this, we get a request for collaboration. And so we've been involved, got involved in a project on data-driven expert systems for irrigation planning with the agricultural and life sciences units, both their research and their extension units. And another one, which is in fact we have some funding from NIST for working on using usage data from public radio for public safety aspects for provisioning of bandwidth. And more recently, we've been involved in a project where we're using computer vision to do rapid disaster damage prediction from geotagged social media. So these things have been follow-ons and have risen from the work we were doing. We didn't necessarily expect to be doing them when we started. So what's the attraction, I think, for faculty of doing operational data science? Well, operational data projects tend to be multidisciplinary. As I said, they tend to integrate vertically from foundations, systems, and practice. And increasingly, this improves our positioning for funding solicitation. So this is a slightly US-centric viewpoint in terms of the particular opportunities I'm talking about. I'd be interested to learn how generally this applies. As I said, there's been a lot of focus on interdisciplinary initiatives and also vertical initiatives. If you look at the National Science Foundation, the Convergence Research Program, the Convergence Accelerator Program, these are programs in which there's this idea of integrating foundations and practice is very resonant. And another sense that if you can do it here, you can do it anywhere. It improves our positioning for the industry outreach, and there are career benefits for students of doing this type of work in terms of having interdisciplinary, this integrative work, if they can show that experience to prospective employees. There's one question we get is, well, why are you doing this? Can't the operational units just do this themselves or buy in the expertise? And operational units typically, well, they may have their own development teams, they may not. or they may be small, and they'll, in any case, they'll buy software from commercial vendors for many tasks. And typically, this is, costly, hopefully it's well supported. New features may be slow to be developed. So, from our point of view, we can bring state-of-the-art ideas and capabilities, and through the faculty, postdocs, and students working on this, and we can respond quickly to develop prototypes. We may end up handing these off to the in-house development team, or it could become a feature request to vendors. So it's not an alternative to in-house development or external development, but it can complement it. Okay, so this talk, I'm going to talk about 3 projects in 2 areas. The first area is in research administration. I talked about this organizational intelligence and the red flag tool for AI compliance, and then the computer vision for game day management. You can look at our website to see more about these other projects. Okay, so let me go to the first of these projects, R-, an organizational intelligence platform for institutional research. And this is a collaboration. It came to us, as an idea from the Division of Research. We've been working with also with the libraries. They have a lot of access to the bibliometric, bibliographic data, which is crucial in this project, and the Department of Visualization. And we have a couple of students working on this too. And so the setting for this is what we call the networks of research. Big picture, how can research better address societal and brand challenges? And these are identified by regional, national, or even global priorities, and increasingly there's funding support to drive participation of research in this area. And I'm talking about energy, sustainability, climate change, animal human health, poverty, education. These are all extraordinarily complex problems. And if we're going to make progress on them, we're going to need multidisciplinary teams. And so from the university's point of view, we can think about how can we firstly identify these emerging problems and get ahead of that in terms of can we support, encourage, foster research teams who are going to be well matched to this problem. For example, setting up workshops, seed grant programs, and so forth to generate a corpus activity in these areas, which we can then position us well to participate in providing solutions to these activities. So the approach here is in network analysis. So what do I mean here? Well, if we think of our internal researchers in the university, the researchers, we can think of those as populating a graph where the researchers are the nodes, and we also have, each of them has topics associated with them, and we have collaborations. So they can be through publications, through joint publications, joint grants, and so forth. But this network also connects to external researchers doing the same thing, same type of activities. It also connects to the research impacts, and these can be, in terms of projects, in terms of outcomes. It can be in terms of, media representation of these activities, public discourse. These topics and reference to the research, reference to the researchers are also part of this network. And there's a broader research agenda. If we think of the research agendas that are being set by government through funding, through solicitations, through strategy and expert reports which come from the government or the national academies, these are all part of this network. These are, we can think of these as text, media, embedded within them topics. So all these are connecting potentially to our researcher network. And so what we want to do is, through our network analysis, we're going to, the setting for this is going to be the union of these networks and the relationships between them. And so practically, what are we doing? So So we want to provide some decision support for our research administration. The motivation here is, firstly, let's identify our research capacity. What are the areas of faculty expertise? What are the clusters of researchers who are working together or could be working together? You know, they have topics in common, but they don't collaborate yet. Or they may have topics which are adjacent or could form part of an interdisciplinary study. So these are candidates for people who could be working together if we wanted to encourage that. So, you know, how does interdisciplinary research evolve in terms of topics, and who drives it? Who are the people in that internal network who are connecting other people and make interdisciplinary research happen? And then if we talk about this broader network, how can we match the capacity we have to funding opportunities to these emerging priorities? And so to drill down further, our approach is to develop profilers of the research expertise, the solicitations, the policy, and the discourse. And then we're going to work with similarity. What we want to do is we match researchers to each other and to solicitations, predict new collaborations, predict links that could occur in this network based on the properties of the objects within them, the researchers, the external resources, and so forth. And if you look on the right here, then there's potentially, if you look at our university, where we have over $1 billion of research expenditures in 2020, then there's a potentially great impact here in terms of can we position segments of the university, of the researchers to capitalize on these opportunities to both have the impact we're talking about in terms of societal impact, but also capitalize on that in terms of being able to expand our operations, research operations, to meet that external need. So if we think of a co-author graph, then we want to understand from the point of view of we think here on the left here, we have researchers, we have lines between them representing co-author, color representing a research area, and size of circle representing the number of co-authors. And so this is one analysis you can do to understand the relevance and the network role of authors within our own network. We also want to understand it within different networks. So this is we've initially done our work based on 3 hand-curated areas which have been sort of verified by our own local experts. One of the challenges we have going forward is to really extend this in a systematic way to all areas, and also to emerging areas, which are, for interdisciplinary research is what we want to do. We don't necessarily know what the right categories are. So in this project, we combine the data. Here we're combining the data. I mean, the libraries run a service called Scholars, which basically is a repository of authoritative data on our internal researchers. Then we have external data from publishers, bibliometric data, from services, Altmetrics and PubMed, for example, which supply that. Institutional data concerning grants, courses. We have our directory, and so this is the raw data which we're going to use to drive this study. Here's a workflow for the similarity analysis that we're using to identify the research areas of scholars. So step 1, we're defining the keyword lists for the research areas. So as I mentioned, we've done this for our 3 areas: water, space, and health. So and then we read in and clean up the keywords for the individual scholars, so we can label them. And then we're doing a term frequency analysis within these within the set of scholars to identify their representative terms for each scholar profile. And then based on that, we can carry out similarity analysis between predefined keyword lists and the scholar profile to identify the research areas within these broad areas for each scholar. And so, our design and implementation. So this comes back to this idea of the components we use within these projects. So key thing here, and a common theme running through a lot of these projects is a dashboard interface using a Python-based open source framework, which is then integrated into a backend. In this case, we have graph databases built on a relational database. Detailing the users, and we have pre-computed reports, but also we can support user queries to drill down and exploration. And then the design, we use a model view controller design, which we found, it was a choice, but it facilitates future development and related reuse in future projects. So here's one thing we've been doing recently, which is what we want to do is when research proposals come out, we want to be able to recommend a set of scholars who are well matched to these proposals. So so what we're doing is in addition to running the process I just described on the scholars, we can also do the same on the NSF proposals website, and then we identify essentially using the same profiling on the same type of profiling on the proposals as we do on the scholars, and then we calculate the similarity between the given proposal and the scholars, and identify the top scholars for research proposals. So, and I'm going to come back and talk about kind of lessons learned from that and future work. But I'm going to talk about a related project. Also came from the Division of Research from their Research Compliance Department, and we call this the Lighthouse Project. The team here includes both folks in our team and also for faculty and the students, but also from the Research Compliance Office. And the setting here is regulatory research compliance. So, regulations apply to research in certain areas: biosafety, animal subjects, human subjects, research. Universities have a responsibility to identify research that goes on in these. And in practice, what they do is label these what we call red flag areas at the proposal stage. And when those are identified, then both at the proposal stage, we're going to provide information and guidance to proposals, but also, if the projects are funded, then these aspects of the proposed work need to be monitored while it's executed as well. And there are requirements for this, both the execution and the reporting of these. And so in the current model, the proposers, when they submit a proposal, indicate in our internal proposal system, indicate the categories on the submission, and then staff experts also review proposals and refine the categories. And so, one potential issue here is, proposals aren't always like many instances where humans are required to provide input and label objects. This isn't 100% reliable, and the staff experts have many proposals to review. So the idea was, can we automate this with natural language processing and enhance the review proposal by automatically generating the categories from the proposal document, and also indicate the text associated with this category in the document to provide guidance and assistance to the reviewers, the staff reviewers, when they're doing their task on these proposals. And we implemented this within the previous framework. We have a web-based interactive front end, which the staff can use, also the proposers can use. We're not doing that, so I haven't been able to roll that out yet. And we have the document analysis, back end, which is doing the analysis and then annotating the text. So, these the red flag lists have been defined for us by the research compliance staff. There's animal welfare, biosafety, export control, privacy, and so forth. So within animal welfare, there are different categories related to different types of animal that are involved in the experiment. So what we're doing is we read in the PDFs of the proposals, transform them into plain text. Again, do the document frequency analysis, which allows us to identify the relevant proposal terms, and then carry out a similarity analysis with the red flags to identify these proposals for potential compliance issues. So, the end result of this is we have a similarity matrix, which is rates a set of proposals against a set of terms, and then uses that to provide these reports to the expert staff. Okay, so both these projects let me talk about kind of the lessons and the limitations we found, and also some work in progress. So, one concern is keywords. So keywords, of course, are really handy for being able to label our documents. And what we found is there's no comprehensive set of detailed keywords and phrases. We can have depth and breadth, but not both. I mean, if you look at the ACM categorizations, then we've got a great set of keywords there, but it relates to ACM topics of interest. If you look at topics provided, for example, by publishers or Library of Congress and so forth, those are broad, but they're not particularly deep. So not having a comprehensive set of keywords was a big limitation for us. So topic modeling can help there, but certainly currently we've been doing this supervised by domain experts on this relatively small set of fields. This doesn't scale, and topic modeling for emerging interdisciplinary fields is challenging because the fields are changing, the relationships between the topics are changing, and so. But what we're doing is we're planning to augment this with a semi-supervised approach. Really, we can exploit this with a wider set of external data, which we're not necessarily going to have to label ourselves. In terms of even working with the people who are going to be the users of our systems, we found there's immense. In terms of designing our interfaces, it seems there's immense scope for being more sophisticated here, to incorporate advanced design for information presentation. And in fact, one sort of knock-on effect of this is that we've opened up a discussion with our own visualization department as to how we can develop how we can develop capabilities for teaching visualization as it relates to data science, data exploration. So that's an interesting development that was in part stimulated by this work. Okay, so the third topic I'll talk about is game day traffic measurement. So this is a collaboration with the Texas A&M Transportation Institute and the Department of Construction Science. Yalam P, who's graduated from the Department of Architecture, is in fact working as a data science in the Texas A&M Institute of Data Science. So the motivation from this came for game day. So college football, like many American universities, is a huge thing. Kyle Field, Texas A&M has the 6th largest capacity worldwide. And, at College Station, the game day events are the largest track events of the year. There could be over 100,000 people involved between the attendees and the workers who are supporting the game. And the traffic management aims are, number one, can we help people travel away in a safe and timely manner after the game? That's the big goal. A more detailed version of this is to soothe the local pinch points. There's going to be pain for everybody, in the sense everybody's going to have delays, but what we want to do is spread that pain around, eliminate the localized long delays, coordinate the flows of pedestrians and cars to minimize interactions between them. And that's both in terms of safety and in terms of getting people safely to their destination, in a timely manner to their destination, and also provide timely information on traffic and pedestrian flows to local police, so they can anticipate how they're going to need to make changes in terms of manual operation of junctions or changing traffic light cycles, which they can do with a pretty low latency. And so the approach we're doing is we want to estimate basically the latent vehicle demand. Not only vehicle counts in roadways, but and going through junctions, but parking garages. How many cars there? How many cars have come out? Because that's going to help us understand what demand we're going to have to satisfy over the next framework in a few tens of minutes. So the approach is based on computer vision, and from computer vision, the data collection capability is already there. Texas A&M Transportation Services has video monitors on its roadways for traffic, and also has some interactions with the local government on that. And also, it's less resource demanding in terms of infrastructure than traditional methods. Human counters, pressure hoses, electric sensors. They're not widely deployed. We really want to make do with the infrastructure we have. There is GPS and smartphone mediated local reporting services, but these have insufficient detail on counts. They can report congestion, but also that is typically not with sufficiently low latency to be useful for these purposes. So the work we've done here is in the first stage of the work is to establish the proof of concept for being able to count vehicles on roadways. And so the input here is we're using pretty much by this stage commodity resources in terms of software to do this. So here's a shot from a camera which is on the side of a parking garage, looking down at a roadway at the boundary of the university campus. And what we're doing is we've shown here that we've divided this roadway into a number of study areas, and these could be lanes, or they could be road junctions, they could be egresses through road junctions in general. And within each of those, we're trying to identify vehicles. So we're using the You Only Look Once software to do that, to identify the objects. And then we're using deep sort to track the objects as they, in real time, as they traverse the areas. And you'll notice we've blurred this. So in all this work, we take great care to obscure any personal identifying information on this and respect people's privacy. The next step is to track these objects, and then by looking at reference points and the geolocations of reference points within the image, we can map this onto onto a vertical representation, vertical view of this area, and then map the locations onto this. And because one advantage of doing this mapping is we can actually talk about vehicle speeds as well, not just their locations. So here's an animation where we have the locations. We've tracked the objects as they go through the zones, and then from these we can do the counts and the transitions between the zones. So how accurate is this? Well, here's an example where we have 61-minute samples which are manually annotated. For our multiple object tracking accuracies is where we're trying to track objects as they go through the set of study zones. The accuracy here is 61%, which is actually pretty close to the state of the art for many applications. And we get better accuracy, unsurprisingly, when we're traffic is closer, hence larger objects, when objects have a smaller angle to the vertical as well. And so this actually led us to some recommendations for our use cases in terms of which cameras we were going to use and what their configurations would be. Here's a turning map application where we want to understand the ingress-egress traversals through a junction. So here we have 12 5-minute samples through an hour during the game day, and where we're looking at the ground truth compared with the measurement. And typically we find we're undercounting, and mainly that's because we have some difficulty distinguishing objects. It is possible to calibrate our inferences against that in order to compensate for systematic undercounting. Means the lessons we've learned from this are really we need to isolate the inconsistencies in the image. One thing that can happen is that the operators do manual panning of the camera we're using. If they although it automatically reverts to the default view after some time, but so we need to be aware of that. Also, light conditions, weather, road surface variation, those all impact accuracy. So those are cases which we either need to detect, flag, and omit, or we need to potentially adapt to. So that's going to be some further work. What we're doing, our work in progress is now to focus on egress counts of videos of parking garages. So why do we need to do this? Well, what happens on the game day, they raise the gates in order to speed up the egress, so we don't have any explicit counts there. So the idea is that we can use video to count those. Pedestrian counts from the routes on the stadium to the garage. We want to learn and predict the egress volumes from the varying pedestrian counts. So there's a kind of delay there. If we get a burst of pedestrians, is that going to give rise to a burst of exits? We want to understand the relationship between those. And also implemented on a commodity computing platform. We don't want to necessarily have a GPU allocated for every camera that's doing the processing. So it turns out that in fact we can run lightweight versions of YOLO on a PC. In fact, several simultaneously. So that doesn't look like it's going to be a problem. So we have a publication on this initial work. So let's see. Just want to check my timing. Okay, so follow-on computer vision problems. I mentioned one construction on risk monitoring. So actually, this is working with the same team as the last project. We're using computer vision-based speed tracking to understand the behavior of driver speed in construction zones. There's another project in emergency management, and I mentioned one in animal science for using computer vision for tracking of individual livestock food consumption from video monitoring of livestock within agriculture. So having thought about those problems, again, I sort of pop up more now to the positioning. So and draw an analogy. So, what were we trying to do in this work? Well, improve the student experience and outcomes at the university, provide decision support to academic leaders and researchers, and increase efficiency and responsiveness of the infrastructure. How are we doing this? Well, we're engaging with the practitioners to understand their problems, and also use access and insights from that to abstract a longer-term research agenda, and work across disciplines to find solutions that integrate science and the systems which are going to have the impact in the long term. And so I've just highlighted the elements here, some of the elements. And the reason I'm doing this is, prior to Texas A&M, of course, I worked at AT&T Labs Research for a while. And if you look at this, highlighted areas here, there's an entirely analogous story at AT&T where, we want to improve the customer experience and the outcomes in the network, and we're providing decision support to business leaders and engineers. And what's the difference between the two contexts? Well, it's mainly, who's doing the work, but the functions, the broad functions and relationships within the two sets are the same. So this led me to think about, in terms of the type of people who are doing the work, what is the difference between industry and universities in terms of interdisciplinarity, in terms of the people doing the type of work, the vertical integration that goes on. So if we think of academic models for connecting disciplines, the assumption is we have superb people working in different disciplines, and of course the academic career structure incentivizes narrow specialization. And so the problem has been how to enable people to work together. And the response has been agencies such as the NSF soliciting proposals for multidisciplinary work. Increasingly, as I mentioned, also this sort of vertically integrated work for example, in the convergence research and convergence accelerators. And many universities have been cultivating responses to these. And I'm arguing that some of the work, for example, in the research dashboard is going to be it can be an effort to do that. But one problem has been how to sustain this engagement beyond the funding period. In industry, I think there's an analogous story, but there are more dimensions. The idea that there are superb people working within and across disciplines, but the career incentives are different. They favor collaboration, knowledge acquisition, skills diffusion. So, we also have superb people working across foundations and practice. And the career incentives to invest time and engagement will pay off for impact. So you're not incentivized to be a narrow person. You're actually incentivized to be to be able to work with people who are different to you in terms of area. All right. So there's a crucial role in the industry for what I call central people who can connect others with greater specialisms that have the knowledge and experience to bring people together. And in some sense, I think a lot of the training work that is going on in universities is focused at training people who can be these central people, who can connect other people. It's not necessarily still a good career path for people who want to stay in academia, but certainly for people who want to go outside, they can be learn to be these connecting people. And I think it's they're greatly become greatly in demand. And there's an organizational imperative for this, of the constant search for the next secret sauce, which is going to be in your products, drive sales, and so forth. But the outcome of this is, we have long-lasting research projects and teams because people are connected. And in the best cases, we're going to, in a research lab, we're going to combine science with impact. And so, I'm making a case for interdisciplinarity here. There are, in terms of getting people working between foundations and practice and disciplines, there are inbound benefits of bringing people together to assemble their skills to meet a specific goal, but there are also these outbound benefits. People get changed by doing this work, and disciplines are refreshed by importing new ideas and methods. The hardest challenge is joining everything in the center. There's less certainty than in single disciplinary work. How do you fit people together? I think it's harder to anticipate problems. And there's a certain amount of friction. People have different languages, different levels of abstraction, even notions of what constitutes research. Some things may be seen as mere, applications or mere theory, depending on your point of view. And there are also, bigger risks and also rewards than for a single disciplinary work. Do you want your tenure case to depend on your success with somebody who works in a different field whose work you don't completely understand, and it's going to take you maybe a couple of years to get something working? But I think refreshment of disciplines is crucial to sustain a momentum beyond this additional problem when you want this long-lasting research venture, not just one-off solutions. So here are my recommendations: that universities should hire more people in the center from industry, agencies, national labs, and mixed roles are okay. It can be research active people, it can be people who build teams, people who are more management admin, who can put things together, and give them enough job security to enable them to take on these tasks. Tenure isn't the only model. Tenured research faculty shouldn't be the only model for stability. And incentivize and support interdisciplinary activities. And I think that my idea is it's sufficient to make projects interdisciplinary, not necessarily people. Even if the established faculty are not going to be interdisciplinary, it's kind of too late to change, but students can become so and develop a capacity for rapid interdisciplinary and vertical integration. Faculty-to-faculty connections take a long time to develop. But we need, when we do have interdisciplinary faculty, we need to incentivize departments to hire them. It's sometimes you can be in the position where, where departments there's a certain reluctance to hire interdisciplinary people because they're not seen as central enough to their departmental interests. Well, I think that's a feature, not a bug, but not everybody shares that point of view. And in data science, we're thinking about consultants, specialists, developers, all of whom can play a role in getting things working quickly. Okay, so here's my summary. Universities are awash with opportunities for data science research, but also development. And these collaborations can help all partners, both in operations, we can get some rapid prototyping done, but also they embody state-of-the-art ideas from research. For faculty, this develops credentials for research and outreach and vertical integration, which is important for these new funding opportunities. And also these new contexts can be a source of further research questions. And for students, you can really get them on track to develop an interdisciplinary profile, which is good in career terms. And if we think of, if you look at how that works together, all those things work together, there's a lot of similarity with industry practice, and I think university hiring practices can learn from these. So thank you very much, and for the invitation, for listening. And at this point, I can take questions.
Thank you very much, Nick, for a very interesting talk. Let me see if there are any questions from the auditorium. For others that want to ask questions, I see one hand raised already. Please raise the hand or put a question in the chat. JK, is there anything from the auditorium?
I don't see hands yet, Mark. Maybe we can start with the online question.
Sure. Rekha, you have your hand raised?
Yeah, thank you. Thanks, Dev, for the interesting talk. So my question is for the project on the research collaboration. What do you think the importance of capturing human behavior as well for the success collaboration?
The importance of capturing human behavior. So could you elaborate of what sorts of behavior you
So in terms of compatibility of people working together, the kind of the way they attack the problem and they have the temperamental behavior. So do you think for a successful collaboration, those kind of behavior should also be captured?
I mean, I don't think we don't have any explicit data on that. I'm thinking maybe we have implicit data in the sense that, I mean, if you look at the network of collaboration, you will see patterns emerge in terms of individuals who have a record of collaboration, who have a record of collaboration with people outside their disciplines. That may be kind of an implicit marker of people who've been predisposed towards that type of work and have been able to form and sustain teams with let's say diverse interests where it's possible. This is hypothesizing here. It's possible that these human factors you've talked about may be a greater factor in terms of sustaining relationships than purely domain-based interests, where people have an actual domain-based affinity which sustains a collaboration.
Yeah. Nick, I was actually going to ask a similar question. Let me use the example in traffic. You take steps on the traffic side, but then people change their behavior. It's like people are told there's a traffic jam on one bridge, so everybody goes to the other bridge, and now there's a traffic jam there. Are you taking that into account?
So, we haven't got to that stage of modeling yet. I think there's a lot of, but I think, this is very much where I think the practitioners come in, because there's a lot of experience from the traffic managers in terms of those what ifs. If there's congestion here, people tend to go there. So they in some sense have a set of scenarios already laid out, and what they want to do is try to understand, get some information about which of those scenarios is most likely to happen, and then they can, in terms of modeling the sort of knock-on effects and knock-on behaviors, they can then adjust accordingly. So that's not something which at this stage we're looking to model explicitly. It's more in terms of the actions that the experts take.
Okay, thank you. I think we have a question from the auditorium.
Yeah, hi, thank you for the excellent talk. So I have a couple of technical questions and a couple of maybe fun comments. So, in the first problem statement, so you considered similarity between documents, and so can you share the accuracy of the methods? We used a TF-IDF method, so maybe you can use something a deep learning method which have gotten better numbers nowadays.
Yeah, we didn't do a comparison with deep learning methods yet. I mean, one sense we have with these, and I think it's an interesting question as to how that's going to help, particularly with these cases where we don't have the experts manual labeling these fields. I think one advantage, one thing we found attractive about the methods we're using so far is they're very explainable. And there's what we found in general with working with operations folks is that explainability is a big plus in terms of their both their kind of understanding and sort of confidence in the methods. So we haven't done that comparison yet, but I think I do see us going that way in the future.
Thank you. And then my second question is so you said a problem is about topic modeling. So maybe classifying documents to a certain topic is difficult. So maybe creating a short summary of a phrase or a sentence instead of one topic like water, health. May that be helpful?
Yes, I mean we're Yes, I mean, certainly we want to drill down to below. Yes, I mean, water is very broad, so certainly we're looking for topics will be, which be phrases, at a lower level than that. But, I mean, water research itself is a huge field. So, so I'm not sure if your question is are we going for more detail on our phrases? But if that's your question, the answer is yes.
Yes, yes. I was asking the same. And also, so in the traffic modeling, so maybe there's you can look at like dynamic traffic signal duration. So like a signal may be read for a long duration of time on a road that is high traffic and green on a crossing road.
Right.
There may be rare vehicles. At least I have felt that issue in Mumbai here a lot.
Right. Well, those are very much sort of operational questions which are taken by the traffic managers and the local police, and that's one of the adjustments that they will typically do. And if we think of how our work relates to that, I mean, our aim is to provide information which would enable them to take those actions in a proactive manner, or at least have advance warning that they're going to need to do that to alleviate or prevent build up of local pinch points of traffic. So certainly that's one of the measures which they're going to deploy on the one hand, that it's part of their menu of actions which they can take, and we want to provide them with information which is going to inform which of those actions that they're going to take in practice.
So, like, yes, sir, sure.
I have a question about the kind of efforts that have been put together to form networks to get teams to do interdisciplinary work.
Right.
How have faculty taken to these kinds of efforts? When a funding agency does this, it's somehow viewed as external. And so there is greater acceptance when an outside funding agency does it. But
Yes.
when Texas A&M University itself does it internally, is there some resistance from the faculty members, or what's the kind of reception you've gotten for this?
Well, that's a good question. And I think, there is certainly one scenario maybe you're thinking about this, which is that, an external funding opportunity comes along, and maybe it's one which generates a lot of interest. So there's an idea that, let's form a team of people who can address that. And that frequently happens, but I think what we're talking about, and perhaps what you're referring to, is actually how do you get out ahead of that? You want to 3 months, a 3-month lead time between the announcement of the call and submission date is not sufficient time to put the right team together. You need to be working on this for some time before that, and I think it's in my role as as director of the Institute of Data Science. One of the things I've been trying to do is provide incentives for sort of coalitions of the willing to form teams that are going to get out ahead of these opportunities. In fact, we have a seed grant funding program, not for individual research, but actually for sets of researchers. We call them thematic labs, to work together in a set of related research projects, but also do all the do kind of the glue around these, which is in terms of developing community, developing seminar programs, developing networks, developing education, course development, case studies, everything, the whole ecosystem around this. And what we found in that is it's not for everyone. Some people really like this model and really want to grab this and run with this, and other people, they're happy really happy with their existing model of more sort of disciplinary-based research. So I think what we found is we found enough partners who want to do this, enough people who want to do this, and perhaps that'll be, if and when we have a success of these, because this is quite a new program, and one of the ideas is it's going to stimulate teams who are going to be well positioned for getting larger collaborative grants around data science applications, data science AI in their areas. That if some of these are successful, maybe this is going to be motivational for other people who are going to want a piece of the same. But in the end, it's to come back to your question. There are certain people who want to take advantage of these opportunities and want to position themselves. Let's work with them.
I have one question. So who is funding this activity? Is it the university, or is it an external funding agency?
So in terms of these activities, so they come from from the Institute of Data Science, which I direct. We have certain recurrent funding which comes. So I'm using that to seed these projects, and then we have some external funding as well. So we've for some of these Cognate projects as well, but some of the people within our broad research community are working on those. The other folks are affiliated faculty. We have joint research proposals, so those are, or they hopefully will produce funding. So it's a mixture of central funding and external funding, which is sustaining this. But certainly we want to get, from my point of view, I've been using internal funding to see this, but we hope it's going to grow to larger funding, external funding.
JK, we're at the top of the hour. Should we continue? You tell me.
Okay, maybe I'll give the mic because he's on the other corner. So I'll ask the question. Okay, I'll ask the question. Okay. So what's the plan to make sure that these proposed solutions are going to run for over time? For example, in the authorship graph, you might want to add notes as papers keeps on publishing, and it might need some manual effort, right, from the authors. So how do you plan to make it running over time? So is it going to be automated, or are there there is some manual effort needed as well? People, as they grow over the career, they don't even update the web page, right? So you have to go to Google Scholar and then find for the paper. So how do you plan to extend the work?
So if I understand your question, we're using certain data we currently have, particularly on the researchers. So how do we make sure that information remains current as we go forward?
Yeah, exactly. It's not just for the first project; it's across the projects. How do you make sure that that everything is going to be current and up to date? Right.
So in terms of specific projects, so in the first project, the local author information is drawn from a service run out of library called Scholars at Tamu, which in part draws on external publication data, but also grant submissions and grant publications to maintain profiles of the users. It has required actions from individual researchers to make sure that their information is current, but it's increasingly transitioning from it's not a question of entering your own publications, it's a question of confirming certain publications are yours. So there is a central effort which is sustained by ultimately by the funding to the Tamu University, which maintains that. In terms of if you think of the second project, so we're drawing on, that draws, on grant applications, which are part of the university information system. One thing that does change there, may change, is in terms of the categories and the keywords, and the expert staff in the compliance office, may add to those or develop those. And part of that's going to come from learning as well, as we go back and understand. They have a manual set of keywords, which is based on their expectations of what projects will in certain areas will involve. So in fact, part of this project will be to in fact learn extend that keyword set through machine learning. In terms of the last project there, the key data for that is the video data there, and I think the main problem we've run up against there is data may expire, or there may be resource issues in obtaining the data, or there may be the data itself may be as I mentioned, there are these cases where operators pan the cameras to different views as part of their management, and then how do we maintain the integrity of the data from our point of view in the system, and the best we can do at the moment is at least to flag those occurrences. I think going forward, the question is, can we have dedicated cameras which are not going to be subject to these occurrences, or can we get a mobile camera which is going to be dedicated to this, located in a particular area for particular events? So I'm not sure there's one general answer to these questions, but in these different projects, we can take different steps to either keep data current over time, or make sure we have reliable data in particular use cases.
Well, thank you very much, Nick. Thank you all for those who attended, and thank you, Nick, for a very interesting talk.
Okay, thanks very much. And I'm going to finish with a shout out to my student collaborators. So actually, I'm still doing work around networking. So Yizhao Feng and Yunhong Zhu, two of my collaborators. Yizhao's now at Meta, please go and do and read their papers, and I hope you'll find them interesting. They're just coming up in conferences.
Thank you.
Thank you.